So the first thing I did, I just wanted to show you how I drew that container. It's a triangular prism. I know that because there are triangles. So I drew the two triangles, and now I connect top vertex to bottom vertex, right to right, left to left, and that's how you draw that figure.
Good time to be taking notes, although we'll do our best to try to get this on our YouTube channel.
Okay. Most of the time it works. Sometimes we have problems. So first thing it says to sketch a net. And remember, I'm going to tell you guys, I have a hard time sometimes drawing a net. I like to just think about the different shapes. So here's a way to do it. And I think I'm going to think about it the way I know how, and then I can go back out and give them the net they want. So if I think about it, there's a rectangle that's down on the bottom. So it's kind of looking like this shape I have here. I know that there's a rectangle down at the didn't chip it. I know there's a rectangle down at the bottom. I want to label the dimensions of that rectangle down at the bottom, 15 inches. And then this space right here. I'm not sure I know what that dimension is. Now I'm going to look back at the problem. And it doesn't tell me what that shape is. So you know what? I have to make an assumption. So in order to figure out what this line segment is here, I'm going to assume the triangles are equilateral. And I can't. Oh, I do know what it is. It's 4 inches here. Why didn't you stop me? Is anybody trying to chime in? This is 4 inches here.
I'm multitasking, so I couldn't.
All right. 4 inches here and everybody else is mute. Okay, so I do know what that rectangle is. If I didn't, I'd have to just make some assumptions and go on, but at least I could show you the rest of my math. But 15 inches here, and this is the same as that one, which is 4 inches. So that's 4 inches. Now I know I have another rectangle on the side, and I lost my prism. It's one of these rectangles here that I'm drawing. So it'll be the one that's like looking right at me. And I know that that's 15 inches. And I want to know what this dimension is right here. And it tells me it is 3.6 inches, or 3 6/10, not 3 6/10 of an inch. And then I have the other rectangle on the other side, and it's going to be the same as this one. So I know I have two of those. I know I have two of those because it's the same thing on the other side. In this case, the two are the same. Because they only gave me one side length, I'm going to have to assume that the other side length is the same. So that would be an assumption. And then I have the triangle faces. I have where the height is 3 inches and the base is 4 inches, and I know I have two of those. Now, they asked me to sketch a net, so I'd have to think if I laid everything out, what would it look like? And that's, sketching a net helps me find the surface area, but I find if I like cut the pieces apart, that would be the same as if I cut this apart too. I'll have to think about how to draw that net out. If you guys have a good idea, I'd love to have it. So what I want to do, if I'm going to find the surface area, I need to find the areas. Remember, the surface area is add the areas. Add all areas together. So let's work with this first shape first. I'll do that in blue. So every time I get to a new shape, I'll do it in a new color. There's the picture, formula. It's a rectangle. Formula then is base times height. Base times height. Substitute what I know. 15 is my base. It's the bottom number, the way I've drawn it. 15, and the height is 4. 15 times 4. That would be the same as 10 times 4, which is 40, and 5 times 4, which is 20, 60.
Very good, Mrs. Brown.
Thank you. 60 square inches.
You did it my way. I like it. You did the break apart.
I like your way.
Can you guys spotlight Mrs. Brown so it stays on her?
Well, when I talk, it stays on me. If somebody else talks, it goes off of them.
Or you could just pin her.
Can you?
Yeah, just when Mrs. Nelson was saying something, it took it off. But if that's fine, then whatever.
long as I'm talking, it stays on me, but if somebody else talks, it goes on to them because I'm in speaker view. I don't know any other way. If you have another way to do it, we would appreciate it. All right, here's another rectangle. So again, the same formula, base times height. I'm just putting that back in my head. Substitute what I know. This time the base is 15 and the height is 3 6/10. Now I could just do this here. And I may just have to do it this way unless somebody's got another way to do it that might be quicker. This is okay.
Calculator.
What's that?
Calculator.
Calculator's another good way. That's my go-to. 6, 9. Sometimes I'm not allowed to have a calculator, or sometimes I don't have one with me, although anymore. 15, and then 3. And we used to say, back in the ancient times when I was in school, oh, like people are going to carry calculators with them all the time. Guess what we're doing now with our phone? We've got a calculator with us all the time. So somebody check with me on the calculator. That would be great. 14. And then I have 1 decimal place, 1 decimal place. I believe it's 54.
Can you try it my way to see if it'll work?
So, okay. So if I think about that.
Not that way. I'm just going to say something. Don't try to break that apart. It won't work. But just if I say 3 times 15 and I know that's 45, would you write 45 for me?
Yes.
And then 6/10, right, is really, 6/10 is really half plus 1 more tenth, right? So stay with me for a minute. What is half of 15? 7.5. And then 1 times 15 would be?
A tenth of 15.
Oh yeah, 1 would be 1 and 5. So if you add those together, does that come to the same answer? 1 and 5.
You want me to add 1 and add 5 again?
Yeah, no, 1 and 5 plus 7 and 5 plus 45. Does that come to 54?
You want me to add this?
Yeah, but you have to line up that decimal point because that you have 45 there.
I do. Okay, so that's a whole. Carry that over. That's 5, 6, 7, 14. Ooh, it did.
Because anytime you see 0.6, right, that's like 1 more than half. So when we're looking at that, we can say half of 15 is 7 and 5. Because remember, when we're saying multiplication, we're using the word of.
And a tenth of a number, I just take, remember, I'm dividing by 10. A tenth of a number, I'm dividing by 10. So that's the same as moving that decimal over. That'll work.
Fun. Okay, thank you. Because it looked like a scary problem to me. I didn't want to, but then when I looked at it, it got less scary.
It did look scary, and I was reaching for my calculator. I was about to. All right, so now I have a triangle. Remember, this time the triangle formula is not base times height. It's 1/2 times base times height, or base times height, and then I take that answer and I divide by 2. Either way, whichever way I prefer to do it. Sometimes I like the half there. Sometimes I like to change it out. My base is 4. My height is 3. I have a lot of opportunities here. I could take half of 4 and get 2 and multiply that by 3 and get 6. I could do 4 times 3 is 12 and then divide that by 2 and get 6. Either way, I get 6.
And remember, multiplying by 1/2 is the same as dividing by 2. So Mrs. Nelson would have done 4 times 3 divided by 2, and I would have gotten 12.
Okay, so my surface area, I need to add them all up, but remembering that I have 2 of these and I have 2 of those. So I have 60. I'll just bring the colors down. So I love working with math and colors. It was a game changer. I didn't even do that until college. All of a sudden, I saw somebody with 3 colored pens, and it was like, what? And 6 and 6. Now, one thing I can look at it as 60. I can look at it as 2 times 54 and 2 times 6. But this time, I don't want to do that because I can see that this 6 going over here makes 60. And this 6, if I put it over here, that makes 60. And now I just have 3 times 60. 3 times 6, 6, 12, 18, and 60 makes that go. So sometimes I want to expand it out, sometimes I want to compress things together.
I like that a lot.
I did too. And this seemed like a very scary problem. I'm still trying to think about how I give them the net that they asked for, the them that wrote the problem.
I know.
You do?
Yes. So draw the large rectangle first in the middle,
Okay.
and then put the two smaller triangle, the two smaller, one on top and one on the bottom.
Okay.
And then
Okay.
the triangular net is attached to the one in the middle.
Ah, perfect. And then I can label all of the sides because that's really the important thing, right? This is 15. This little side here would be the 3 6/10. The 3 6/10. This would be the 4 and the height of 3. Oh, thank you very much. I was having a hard time visualizing it. And the idea behind a net is to help you do this part. So if the net helps you, do that. If just breaking the shapes apart helps you, and of course, the more different ways you can do something just helps you double check. I was going to see on this problem, I was going to see if it made sense back when I did it this way. If we hadn't checked it another way with Mrs. Nelson, I was thinking, these two problems are very similar and my answers are very similar, and it makes sense if this is 60, and I was feeling really good about that 60. 3 6/10 is just a little bit smaller than 4. So my answer should just be a little bit smaller than 60. I'm always trying to get some confidence in my work and going, yeah, I'm feeling good about that. Thinking about that a little bit. So that is one of the problems today on the independent practice for 15.1. Tomorrow, or Monday rather, we're going to be moving into 15.2, going into volume. And volume is one of my favorites too.
And that's the way you find the surface area of a triangular prism.